So my name is Dr. Nefron. I think you already know me. So today we'll be introducing us to limiting and excess reagent. So now, before we start, the last class I actually gave you the formulas for calculating number of moles. So I gave us different solutions and how to actually solve for the number of moles. Now, so the best part of the stoichiometry is how to indicate limiting and excess reagent. Now, the first thing is to know what is called the active moles. The first thing is to know what is called the active mole. Active mole is very, very important. Without this active mole, we can never indicate either the reagent is limiting or excess. Now, so what's the formula for active mole? Active mole is equal to calculated mole divided by stoichiometry mole. Calculated mole over stoichiometry mole. Okay, now what do we call calculated mole? Calculated mole is the number of moles that you calculate by yourself in a equation. If they give you any parameters and you now use that parameter to calculate the number of moles. So the number of moles you calculate using those parameters is called calculated mole. Stoichiometry mole is the number of moles in a balanced chemical equation. Now this stoichiometry mole actually serves as the coefficient of either element or compound in a balanced chemical equation. For example, now I give you A like 2A plus what? Plus B equal to 3C plus 4D. Now, assume that this is a balanced chemical equation. Assuming that this is a balanced chemical equation. Now, the stoichiometric mole of A is 2. Stoichiometric mole of B is 1. Like coefficient of A here is 2. Coefficient of B here is 1. Coefficient of C here is 3. Of D here is 4. So this coefficient is called their stoichiometric mole. So that's why we usually use it in titration. For example, now we have H2SO4, abi now react with sodium hydroxide to give us what? To give us NH2SO4 plus what? Plus H2O. Now if you balance this equation now, we have 2 sodium and put it 2 here. I get now. So I have 2 hydrogen here, 2 hydrogen here, making 4 hydrogen. I'm putting 2 here. Now don't forget that in titration there's a formula Na over Nb, right? Because there was CAVA over CBVB. Now you see the meaning of Na means what? The stoichiometric mole of acid. Na means what? Stoichiometric mole of the acid. While Nb means what? Stoichiometric mole of base, not the active mole or calculated mole. Stoichiometric mole of A and stoichiometric mole of B. Now from here now, this is my acid, this is my base. So the stoichiometric mole of acid here is 1. The stoichiometric mole of acid here is what? Is 1. While the stoichiometric mole of base here is what? Is 2. Because the coefficient of the sodium hydroxide here is what? Is 2. So that's what's called the stoichiometric mole. Stoichiometric mole is the number of moles obtained from a balanced chemical equation. Now, having known that, let me now explain how to calculate these active moles. Now, imagine I have 2A and you are given the mass of that A to be what? To be 2 grams. And the molar mass of A is given to be what? To be 5 grams per mole. 5 grams per mole. Now, plus B. So we are giving the mass of B to be 1 gram and the molar mass of B to be 2 grams per mole. So to give us C plus D. Please listen to it very well. Now, there are some questions that we are going to be provided with 2 masses for either for what? For the two reactants. For example, now our reactant here is A and B. So we will be given two masses for each of them. Now this one will have its own mass, this one will have its own mass, and they give them their molar mass. Now if you are given a question like this, you give two masses and two molar mass. So what's supposed to come to your mind is what? It's like calculate the number of moles for the two of them. How can we do it? Look up. Now I was given the mass number of what? Of the mass number of the mass of what? Of element A, and I was given the mass of element B. What am I going to do, class? Now we are going to calculate what number of mole of what? Of A. Using what? Using mass over molar mass. Number of mole of A equal to what? The mass of A over molar mass of A. Now if you look at the mass of A given to us in the question, it's what? It is 2. I get it now. 2 divided by, now the molar mass of A is what? Is 5. Is that okay now? So 2 divided by 5 will give me what? Will give me 0.4. 0.2. Are we there? 0.2. 0.2. So to give what? To give me 0.2. Because if I convert 0.2 to decimal to what? To know to proper improper fractions, I'll be having what? You just put 10 here. So it will be what? It will be 2 over. Sorry, it's what? It is what? It is 0. What? 0. 4. So 0.4. Now 0.4. Yes, 0.4 because if I convert it to what? To fraction, I'll be having 4 over 4 over 2 here to 2 here 5. 0.4. Sorry, 0.4 moles. Now you see the number of moles you calculate here is called calculated mole. What I call it is called calculated mole, and you can never use this number of moles until you convert it to active mole. That means active mole of A will now be calculated mole divided by the stoichiometry mole of A. And I told you that stoichiometry mole is the coefficient of A in the balanced chemical equation. So what I calculate here is called calculated mole. 0.4 divided by what is stoichiometry mole of A? 2. So we will give you what? 0.2 moles. That's the active mole of A. Now I have calculated the active mole of A. Now let me calculate that of B. Now to calculate the active mole of B, I am going to apply the same formula. Don't forget that active mole of A is given as 0.2 mole B. Alright, now let's do the same thing for what? For B. Number of mole of B equal to the mass of B over molar mass of B. 1 over 2. And 1 over 2 equal to what? Equal to 0.5 mole. Plus, what I calculate here is called calculated mole. Because the number of mole you calculate by yourself is called what? It's called calculated mole. And you can never use it to find anything the equation centered upon. So I have to convert this to active mole. So active mole of B will now be equal to what? The calculated mole of B over stoichiometric mole of B. What's calculated mole of B? Is 0.5. If you go and look at the stoichiometric mole of B, the coefficient of B here is called stoichiometric mole, and I have 1 here. Divided by what? Divided by 1. So it will give you what? 0.5 mole. Now, class, compare it together. 0.2 moles and 0.5 mole. Which one is small? It is smaller. 0.2 is smaller compared to 0.5 mole. Now, the reagent that have the smaller active mole is called limiting reagent. Is that okay? The reagent that have the smaller active mole is called the limiting reagent. While the reagent or the element that have the higher active moles is called the excess reagent. So that means in this particular demonstration, A is limiting reagent. Why what? Why B is what? Is excess reagent. Again, you will firstly calculate the number of moles of each of the elements in the reactant using what? Active mole equal to calculated mole over stoichiometric mole. The number of mole you calculate by yourself is called calculated mole. The number of mole in a balanced chemical equation is called the stoichiometric mole. So if you calculate the active mole, now you now go and compare the one that have the smaller. So any compound or any element that have the smaller number of active moles, it is called your limiting reagent. The one that have the higher number of active mole is called the excess agent. And note that we can never use the number of mole of the larger active mole to calculate anything they ask us to calculate. You'll be using what? You'll be using number of mole for the limiting reagent, which is 0.2. That means if they ask me to calculate anything in a question, I'll be using 0.2. That is the number of active mole for limiting reagent, not the excess reagent. So this is where we are going to stop for today. So in the next class, we are going to solve more questions on this particular demonstration. Thank you. Subscribe to my YouTube channel. Thank you so much.